All right, welcome to another video. This is the start of our functions unit, probably one of the most important units that we're going to cover. In this video, I think we're only going to get through probably the first 2 pages. At least that's the goal. So here we go. So what is a function? Well, when we're talking algebra 1, we're going to refer to a function as anything where you input one variable, you input one thing, and you output something else. So typically, we refer to x as our input value. So we input x into the function. Okay, think of the function as some machine. It's got some stuff in it. You know, we do some things to it, and out pops y, our output. Okay. You've already seen functions, you know, when you write the equation of a line, y equals mx plus b, something like y equals 3x plus 2, that's a function where you plug in x and you get out y. Instead of writing it as y equals 3x plus 2, we could also write it f of x equals 3x plus 2. Note that when we see this f parentheses x, we read it f of x. This is not f times x. This is not f times x. Not f times x. Okay, so if I had a function like this, f of 3 equals 5, f of 3 equals 5 means you input 3, you plug in 3, so x is 3 and y is 5. We can map that to a coordinate point, xy or 3, 5. Okay. Another name for our input is our independent variable. Okay, so x is an independent variable. You plug things in, you change it, and y, because the outcome depends on x, we refer to y as a dependent variable. X is independent, y depends on x. Y is the dependent variable. How can we tell if something is a function? We can tell something is a function if for each input, there's only one output. In other words, for each x that you plug in, you only get out one y value. Okay? So if you have a function where f of 3 equals 5, it's always going to equal 5. It's never going to equal 6 or 7 or some other number. Okay? If you graph this, you know, we have some function and we graph it. Okay? The way we can think about this is if it's a function, that means I can take a vertical line, pass it over the graph, and I'll only ever touch one point on the graph at a time. So this little sketch here, this is something that is a function, right? If I had something such as this, what if we had, here we'll do it without the axes. What if we had a graph that looked like that? Does that pass the vertical line test? No. Right? There's 2 points where they have the same x value and different y values. Right? So that would not be a function. Okay. Another way to talk about the x values or the inputs is to think about the domain, right? To refer to it as the domain. So if I'm asking what is the domain of a function, I'm saying, hey, what's all the possible values that you can plug in, right? What are all of the possible x's that can be plugged into this function? All x. That you can plug into f of x. Okay? On a graph, you can think of it as how far left and right the function goes, because the x-axis goes left and right. So you think, how far along the x-axis can I go on this function? For range, that deals with the outputs, or the y values. How far up and down, right? How far up and down does the graph go? In other words, what are all of the possible output values, right? What are all of the possible y values that this function can spit out? So let's do a couple examples. Okay, so here we have a relation. We have a bunch of ordered pairs. Okay, and our domain is going to be all of the x values. We're going to write it in set notation, so we're going to use these squiggly brackets. Ooh, that's a little too thick. Okay, so what are all our x values? Let's see, 6, 5, 1, 1, and 7. That's our domain. All of our x values. Our range is going to be all of our y values. And it doesn't need to go in the same order. You don't need to write the ones that match with 6 and 5, etc. You can put them in whatever order you want. So our range, -7, -8, 4, 5. All our possible y values. Is this a function? In other words, do you see anywhere where an x value repeats, but it has a different y value? No. So we say, yes, this is a function. Okay? This is a function. Let's look at example 2. In example 2, our domain, let's see. 2. Oh, look, 2 shows up again. I'm not going to rewrite it. I don't need to rewrite it. Okay? 2 shows up twice. The other x value that shows up is 5. That's it. That's our domain. Okay. Our range, on the other hand, let's see, we have a 5. We have -3. And we have 7. Okay. Is this a function? Well, if you notice, I have 2 points where x is the same, but y is different. So in other words, I have one input going to multiple different outputs. That fails the vertical line test. That's not a function. So we're going to say no. Okay? Because this 2 is being mapped to both 5 and to -3. Okay? We can only have x going to one y value. We can do this from a picture as well. So if we do it from a picture, the bubble on the left is your x, and the bubble on the right is your y. Okay? Your inputs and your outputs. Plug in x, get out y. So our domain is everything on the left. And we're going to write it in order this time, because that's normally how we do it. 2, 4, 8. Okay, our range is on the right, and I'm going to write it in order. Again, because we typically write our sets in order. You don't have to, but it looks nicer that way. Is this a function? Well, let's see. Do you have any repeating x values that go to different y values? If you look, this x, this 8, is going to 2 different y values. It's going to 5 and 7. So that means the point 8, 5 and 8, 7 would be on the graph of this function. That fails the vertical line test. No, it's not a function. Okay, you try 4. All right, let's look at the next page. So on the next page, we're going to be plugging things in or evaluating functions. Okay, so when we're evaluating functions, remember, this is f of x. You're plugging an x value in and you're getting out a y. So this is the exact same as writing y equals 4x plus 10. Okay, so if I'm asking you find f of negative 3, just replace the x here with negative 3. So 4 times negative 3 plus 10. So what is that? Negative 12 plus 10 or negative 2. So we're going to say f of negative 3 equals negative 2. You can try the other ones. We can even work backwards. If we're told f of x equals 58, we can use that to find x, because remember, y equals f of x. So in other words, y equals 58. And because f of x is also equal to 4x plus 10, we can set this whole thing equal to 4x plus 10. And we can solve for x. So go ahead and solve for x. Subtract 10 from both sides. Divide by 4. Let's see, 48 divided by 4, we get 12 equals x. You can try the other two. Something else you can do is you can use your calculator to plug stuff in. You can use Desmos as well. I'll tell you what, we'll use Desmos because it's quicker, a little easier that way. So let's see, if we plug in, oops. All right, let's type in the function from our notebook. F of x, g of x, I'm sorry. So we're told g of x equals x squared plus 4x minus 5. Evaluate. So if we want to do in Desmos, we can just type g parentheses and then whatever number, negative 3. Boom. And it spits it out for us right there. See that? It's kind of nice. You can also, let's see, g of 3, try g of 100. Gives it to you right there. Not too shabby. I like Desmos for this. Okay, now we're given two graphs. So we're given f of x, so that's the wiggly one, and g of x, that's the straight line. Find f of 2. Now remember, y equals f of x, or y equals g of x. Okay, so if you're asked to find f of 2, you want to see when x is 2, what is the y value on this function f? Okay, so we go over to a 2, 1, 2, and it looks like the function f is actually crossing through the x-axis there, right? So this point would be 2, 0. So we say f of 2 equals 0. Okay, so what we're doing is we're finding the x value. We're going to the x value, and then we're seeing what's the y coordinate, right? What's the y coordinate? So g of 3, let's see. Or let's do g of negative 4. How about that? Let's do g of negative 4. So we're going to go negative 1, negative 2, negative 3, and here's negative 4. And we go up until we hit g. There's g. What's the y value? 1, 2, 3, 4, 5, 6, 7. Negative 4, comma, 7. So g of negative 4 equals 7. Okay. If f of x equals negative 5, so in other words, if y equals negative 5 on f of x, find its x value. So we're going to go down to negative 5. 1, 2, 3, 4. There's negative 5. And we're going to look until we hit the curve. There it is. Okay, there it is. There's the point. So negative 5, what's our x value? 1, 2, negative 3. So in other words, f of negative 3 equals negative 5. You try the rest. Where do you think f of x is equal to g of x? Think about when we did systems of equations. If your thought was f of x equals g of x, where the two lines intersect, then you're correct. Well, not lines, I guess where the line and the curve, so where the graphs intersect. Let's see, that would be here, here, and here. So we have the point 2, 1. We have the point, this looks like negative 1, 1, 2, 3, 4, and negative 2, 5. So at what x values? At x equals negative 2, negative 1, and 2.